Hello everyone, welcome to my channel. In this video, I'm going to discuss the example for probability. Kindly refers to the questions. A certain medical disease occur in 1% of the population. A simple screening procedure is available and in 8 out of 10 cases where the patient has the disease, it produced a positive result. If the patient does not have the disease, there is a 0.05 chance that the test will give a positive result. Find the probability that at a random selected individual. So my suggestion is to have a tree diagram. So number one, we must have the disease. So here we have the disease or complement of the disease. So the probability is 0.01. The rest will be 0.99 for the person that does not have the disease. Next, a simple screening procedure is available and in 8 out of 10 cases where the patient has disease. So means that refers to the disease D1. So it said it will produce a positive result. So here we will have a positive result. Or we can say a negative result. So P complement will be the negative. Repeat the situation, positive result, negative result. So based on the questions, we have 0.8. So meaning that the probability is that a patient is positive given that the patient is having a disease. And the situation would be 0.8. Or the formula can be expressed as probabilities of P2 intersect with D1 over the probabilities of D1. Next, if here we have 0.8, automatically here we will have 0.2. So meaning that the probabilities of the patient to be negative given that the patient is having a disease. And the formula will be the probabilities of the patient negative intersect with disease over the probabilities of the patient having disease. Next, what we can see is if the patient does not have the disease, so kindly refers to the D complement, there is still a chance where we have 0.05, the test will be give a positive result. So here we will have the situation 0.05. So the probabilities of positive, given that the patient is healthy, and we have the probabilities of P2 intersect with the complements of disease over the probabilities of complements of disease. Finally, we have 0.95 and we have the probabilities of the patient having negative in the test given that the patient is healthy. And we have the formula probabilities of negative intersect with the healthy people over the probabilities of the healthy people or without the disease. So here we have the tree diagram. So find the probability that a randomly selected individual. A. Find the situation that the people or the person does not have the disease, but give a positive result in the screening test. So the situation will be the probabilities of the person does not have the disease, where we have D1 complement, but give a positive result in the screening test. So meaning that intersect with the positives. So here we have the situation. So kindly refers to the tree diagram where we have situation number 1, number 2, number 3, and number 4. Kindly refers to the situation number 3 where we have to cross multiply the situation. So we will have the probability that the situation is positive given that the person is healthy. Multiply with the probability that the person is healthy. So where we will have 0.05 multiply with 0.99. So the answer will be 99 over 2000. So that will be the answer for A. Kindly refers to B. Give a positive result on the test. So meaning that we have the probabilities of P. Kindly refers to the situation number 1 and number 3. So meaning that we are interested in the probabilities that the patient is positive and with the disease. Or we have the situation, the probabilities that the patient is positive and the person is healthy. So make use of the situation number 1 and number 3. Kindly cross multiply the situation. So we will have 0.8 multiplied with 0.01 plus 0.05 multiplied with 0.99. So the final answer will be 23 over 400. Kindly refers to the question C. Annie has taken the test and her result is positive. Find the probability that she has the disease. So meaning that where we have the probabilities that the situation is disease, given that the test is positive. So refers to the formula where we have the conditional probability. So the probabilities that disease intersect with the test, which is a positive, over the probabilities that the test is positive. So kindly make use of the situation number 1, where we have 0.8 multiplied with 0.01 over where we have probabilities that the patient or the person is positive, where we have 23 over 400, which is the total probability. So finally, the probabilities that the person has disease, given that it is a positive in test, is equals to 16 over 115. So here we are, and thanks for watching.